let's take a look at today's do now. We have find f of 4a minus 3 if f of x is given to be x cubed minus x. So I'm going to let you guys pause the video, try this out on your own, and then we will compare our answers. All right, so for this one here, we have our new input of 4a minus 3, our original input of x. Everywhere we had an original x, we inputted the new input of 4a minus 3. I did my distribution. There was a lot of algebra happening here, combining like terms. Finishing off with f of 4a minus 3 is equal to 64a cubed minus 144a squared plus 104a minus 24. So let's take a look at today's thinking. How do we perform operations with functions? Operations with functions. Let's say we have a function f and a function g. We have been given some sort of sum. So here what we have is function f and g are being added. And we have an input. For this type of problem, what we are going to do is we're going to take the f function, input that given input of x, add, because we are summing, right? Adding these, take the g function and input the same input of x. So two things to pay attention to is you want to pay attention to the operation that we need to use, and you do want to pay attention to the input we are inputting. So the second one here, we have a difference. Looks exactly like the sum, only that there is two functions, f and g, and we have some sort of subtraction. Again, we have a given input. So for this type of problem, we are taking the function f, inputting x, subtracting that when my input is also x. We have some sort of product. So again, we have two functions, f and g, that are being multiplied together. We have a given input of x. And for this specific operation, we are taking our function f, inputting that given input of x, multiplying that with our g function with the same given input. And the last operation is a quotient. We have two functions, f and g, and they are being divided. We have a given input of x. And so something like this, what we would have is take our function f, input the given input of x, divide that by the g function with the same given input. Super important, the denominator, which is our g of x, cannot be equal to 0. It cannot equal 0 because that would make this specific problem undefined, and we do not like that. Let's take a look at our example. So perform the basic operations with functions. We have been given two functions, f and g. F of x is 3x minus 1, and g of x is x squared minus 2x. We have a mixture of operations we want to perform and different inputs. So what we have for this first one is f plus g. So the operation we are doing is we're going to be adding. We have some sort of input. So what this is asking us to do is to take our f function, input that x minus 1, we're adding the g function in which we're inputting the same exact input. All right, so we are taking the f function, and the f function is stated as 3x minus 1. This x is the original input, both for g and f function. So what we are going to do is what we did in the previous lesson, but we're doing two different functions in one shot. So what we are going to start off doing is look at the f function, input the x minus 1 piece. So my function is 3 times the input minus 1. And what we are going to do to that is add the g function. So the g function is stated to be the input squared minus 2 times the input. So every place that we had the original input of x, we're replacing that with the updated input. As we know it, the new input. All right, so let's clean this up. Let's distribute, combine like terms, and see where we end up. So what I want you to pay attention here, and what I did specifically, is I wrapped this x squared minus 2x plus 1, which is what we got from distributing x minus 1 twice, right? That exponent of 2. I wrapped it around parentheses because in this case, it's not really going to affect it. We do have an addition, but very important, signs change when we're subtracting. So just paying attention to that little notation there. And finally, when we combine like terms, we would get x squared minus x minus 1. Here, what we do want to do is we want to write our answer in standard form. So what does that mean? That means that we're doing and writing the highest exponent first and in decreasing order. All right, let's try number 2. Same two functions, but this time what they are wanting us to do is to subtract. We have our input of x plus 1. So I'm going to specify this as our new input. So in this specific problem, what is it that they want us to do? They want us to take the f function, input x plus y, subtract the g function, where my input is x plus y. So I am going to include an extra piece of information here is I'm going to wrap that g function around with extra parentheses or extra grouping symbols because we are subtracting a binomial, right? The g function is a binomial, x squared minus 2x. So we're going to start by taking the f function, which is 3x, but this time our input is no longer x, it's x plus y. We are subtracting 1. What we want to do is subtract the g function, and the g function consists of input squared minus 2 times that input. So again, everywhere I had an original input of x, I am replacing it with the new input. And just to make sure I don't mess up, I am wrapping the g function with extra grouping symbols. So let's clean this up. Let's do distribution, combine like terms, and so forth. Keeping the grouping symbols or extra grouping symbols around the g function. And lastly, let's distribute that negative to everything, getting rid of the extra parentheses or extra grouping symbols. And combining like terms, one more step. This would be my final answer. All right, let's try number 3. For number 3, we have our f and g function. What am I being asked to do to those functions is multiply. We have our new input of 2x plus 1. So what is it that we are doing? We are taking the f function, input 2x plus 1, take that and multiply it by the g function, in which my input is 2x plus 1. So let's set this up. We have the f function, which is again 3x x minus 1, but instead of writing the x, I'm going to write the new input. We are asked to multiply, so I am just going to put this around extra parentheses just so I can think of it as just distribution. And our g function is x squared minus 2x. So in this case, the input squared minus 2 times the input. And I am going to do everything inside the parentheses on both pieces, the f function and the g function, and then I will be able to multiply them through. All right, after doing my distribution and combining like terms, we end up with 24x cubed plus 8x squared minus 6x minus 2. For number 4, I am going to let you guys try this one out. We have two functions, the f and the g. What is it that we are being asked to do? We are asked to divide, in which we have been given a new input of 2 minus x. So let me just set it up and then I'll let you guys pause the video. So we are taking the f function, inputting 2 minus x divided by the g function, in which my input is 2 minus x. So at this point, I am going to let you guys pause the video, do your work, and we will compare our answers. All right, so for number 4, final output of negative 3x plus 5 divided by x squared minus 2x. And for our last problem, we have the most complex type of problem that you might see. We have 2 times the f function minus 5 times the g function. So this is the hardest of all. Here we have a number in front of the f function. So this is telling us to take the f function and double it, multiply it by 2. And same thing for the g function. The g function is being multiplied by 5. And the operation in between is the subtraction. We have our new function, new input of 3n plus 2d. So for this specific problem, this is how you would do it. So it's pretty much the same thing that we've done. It's just a mixture of operations happening all at once. So we're taking 2 times the f function, in which the input is 3n plus 2d, subtracting that, and we have 5 times the g function, where my input is 3n plus 2d. But anytime you are subtracting, do not forget to include extra grouping symbols. I normally put brackets, but you can put extra parentheses if you like. So let's do this. Let's just think of f function on its own. So what we're going to do is we're going to deal with the f function. What does the f function state? That tells us to take 3, input the new input, and we have minus 1. That's the definition of the f function. But to that, what we have to do is double it. So let me work downwards, right? What we are going to do is we're going to work with everything inside, distribute everything inside, combine like terms within everything inside the parentheses, and then last take the 2 and distribute it in. So let me set up my g function. We have subtract. Let me start with my extra grouping symbol. We're going to take 5 times the entire g function. The g function is x squared minus 2 times x. And to that, once I do everything inside, this is everything inside, I am going to distribute that 5 to everything. And then I'll distribute the negative, changing all my signs, and then I will be able to combine all of my like terms. So we have twice the f function, and my f function simplified would be 9n plus 60 minus 1. There's nothing else to combine for the f function there. So lastly, I will distribute that too. But let me just keep writing. We have 5 times the g function. So let's see what's happening inside the g function. If I were to expand 3n plus 2d to the second power, we would end up with 9n squared plus 12nd plus 4d to the second. And then we would distribute that negative 2 to 3n plus 2d, giving us negative 6n minus 4d. Within this, again, looking at the inner parentheses, there's no like terms that I need. So I will start distributing these numbers in front. All right, so after doing my distribution, this is where we end up. And lastly, let's distribute that negative so I can get rid of those extra grouping symbols, those brackets. And I am going to change the order. I am going to put my n squared, my nd, and my d squared first, and followed by nd and my constant. And we end up with negative 45n squared minus 60nd minus 20d squared plus 48n plus 32d minus 2. So keep learning, keep growing, and I will see you in our next video.